Right, everybody say hi, Claire. Or whoever's watching this, and they crickets. They talk the whole time, and now they won't say anything. Okay, whatever. All right. So this is part B of section 1.6. 1.6 part A we did yesterday. Part B we did today, and I just kind of introduced this lesson saying that when we're trying to solve these equations, we're trying to find the place where two lines cross each other. So these two lines are crossing at the point -2, -3. Except I want to find that place without having to graph. I don't want to graph. Graphing is yucky. We don't want to do that. So we have two options. One of them is substitution. The other one is elimination. Chase just asked which one's easier. It depends. It depends on the equation that you are given. Okay. I like elimination better, but it depends on the equation that I'm given, which one I'm going to do. So this first thing that they have going on here says this. This guy has a computer support business, and he estimates that the cost to run this business can be represented by y equals 48x plus 500, okay, where x is the number of customers. He estimates that income will be this equation, okay? So what I'm trying to do is I have two equations that are going to maybe somehow go like this, and I want to find the place where those two things are going to intersect each other. That's what I'm trying to find, okay? So what will his profit be if he has 60 customers, whatever? How many customers will he need in order to break even? This is the break even point. This is equilibrium. I'm trying to find that point right there, okay? So the two equations that I have, I'm going to write them down here on top of each other. 48x plus 500 and y equals 65x minus 145, okay? So I have those two equations right here, and we want to be able to substitute, okay? So I have these two guys, and I want to substitute. I have that y here is equal to 48x plus 500. But then they tell me, well, y is equal to this guy now, 65x minus 145, okay? In the top equation, I have y by itself. So what I can do is I can take this y right here, 48x plus 500, and I can plug him in for this y down here, right? If they told you x was 2, and then they give you a big long equation, you plug 2 in for x, right? This is just telling you y is that value. We're going to plug that in for y in the second equation, okay? So what's going to happen here is this y is going to get replaced with the 48x plus 500. Does that make sense?
Yes.
Okay. 48x plus 500 is that first piece. That's going to be equal to the 65x minus 145. Do you see what we just did? I took this guy and I plugged him in right here. Okay. Now, how many pieces are up there in this thing that we have now? How many pieces do I have? I have 4 pieces. 1, 2, 3, 4. And the beautiful thing now is I don't have any y's. I only have x's. Okay. So we want to get the x's by itself and the y and the numbers by itself. So 48 and 65. Which one do you want to subtract to the other side? Which one would you like to move? Normally I have the x on the left side, but I think maybe in this case I want to subtract the 48x. Can we do that? Minus 48x, because then I won't have to deal with a negative number. So I have 500 is equal to 65 minus 48 is, I don't know, 17. Help me out here. 17.
Yeah.
17x. Okay, 17x minus 145. Okay, then what? Add the 145. I want to add 145. Okay, so 17x equals 645. And then divide by 17. And x is equal to, what's 37.9. That's what you got? 645 divided by 17. Are you sure?
Yeah.
Okay. X is 37.9. Am I done?
No.
Not quite. We've got to find y now, okay? Well, I have two equations for y. I have this top one right here, and I have this bottom one right here. And I know what x is, but I need to solve for y. Which one would you like to plug into?
The first one.
Does it matter?
No.
No, we can solve them. We can plug in for any of them. So Jake wants to plug into the first one, so let's do that. 48 times 37.9 plus 500. Okay, so take 48 times 37.9 and add 500 to that. What is the y?
2, 3, 1, 9,
2319.2.
Yeah.
Okay, there we go. And I think that's in dollars. So X is 37.9 customers, and Y is $2,319.20. That's where this point is located. If I put it as an ordered pair, 37.9, comma 2319.2. Okay, I'm gonna skip the last part where it says what will his profit be if he has 60 customers. We're not gonna do that part. We're only gonna find that equilibrium point. Okay, we'll skip that
What
part.
would you do if it said you just put in for X?
Yes, but in which equation? What will his profit be? So we want to put him into the second equation where it has income. Actually, we would want to plug it into both equations and subtract them, right? Because profit minus cost is, or excuse me, income minus cost is profit. We're not going to worry about that. You see? This is income.
Yeah.
This is cost. We would plug it into both and then subtract the two. Okay, but I don't have room, so we're going to skip that part. Okay? All right. Do you want another example of substitution?
No.
No? You're sure?
Yeah.
We'll do another example of substitution down below. Okay, but let me show you of one of these two. One of those two down below. That's already on the sheet. It's already on the sheet. So I'm not adding another problem. Example 5. Use elimination to solve. Okay, so this one is set up ready to go for elimination. Okay, I told you sometimes it's easier to do substitution, sometimes it's easier to do elimination. So up here I had the y's solved for, so it was really easy for me to plug one into the other one. But if you look at the way that this is set up, I don't have any of the x's or y's solved for. They're not by themselves. So if I would want to do substitution, I would have to solve for one of them, which is kind of gross. Okay, so in this case, I'm going to eliminate. And what you do when you eliminate is you're going to add both of these equations together and hope that one of the variables crosses out. Okay, so I add them top and bottom, and don't write this down yet. If I take 5x and I add it to 8x, that would give me 13x, right? And if I have 3y and add it to 3y, that would give me 6y. None of those cross out. I want to make one of them cross out. So what can I do to one of those equations to make them cross out?
You can make one of them minus 3y.
Right, make one of, okay, so let's just do that to the bottom. So what I'm gonna do is this bottom equation, I'm gonna take everything times a negative 1, right? That will make the 3y negative, okay? So on the top, I'm just gonna rewrite 5x plus 3y equals negative 19. We didn't do anything to him, he's just dropping straight down right here, okay? But now, I'm gonna multiply everything by negative 1. So that will make negative 8x minus 3y equals, what will that be? Positive 25. Okay, positive 25. Now I'm going to add them together. So what's 5x and negative 8x make? Negative 3x. That's going to, I've added those together. 3y and negative 3y, those are done. That's crossed out, so I just have equals, and what's negative 19 plus 25? Negative 19 plus 25, or switch it around, what's 19, or 25 minus 19? It's positive 6. 25 minus 19, positive 6. Then, really super easy, I divide by negative 3, divide by negative 3, x equals negative 2, you betcha. Done?
No.
Not yet. Now we have to plug back in. Which one do you want to plug into? The top one or the bottom one?
The top one.
Sure, the top one. So 5x we now have found is negative 2.
When you plug back in, and if you do want to do the bottom one, you keep it negative.
It doesn't matter. So technically I could plug it into this guy, I could plug it into this guy, or I could plug it into this guy. It doesn't matter. Good question though. It does not matter. So options, wonderful, we have options. Okay, so we picked the top one, we're plugging negative 2 in for this y right here. La 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 la, okay. So 5 times negative 2 plus 3y equals negative 19. All right, so this guy is negative 10. Negative 10 plus 3y equals negative 19, and then what?
Add 10.
Add the 10 over. Okay, plus 10 plus 10. So 3y equals, what's negative 19 plus 10?
Negative.
Negative 9, and then divide by 3, and y is
Negative 3.
-3. Okay, now let's write our answer together as the point -2 comma -3. And why do I care about this point right here? What does that do for me?
That's when breaks even.
Yes, that's my break-even point. This is where the two lines cross each other, is at this point. Whatever they may look like. That's why I care about that point. I use that as a test or quiz question, or yeah, quiz or test question. What does that point do for me? It is a point where those two lines cross. Yes?
Oh yeah, could you solve both of these equations and get the same answer by doing substitution?
Yes. Yes. Good question. Another good question. Can you do substitution with this guy and get the same answer? Yes, as long as you do everything correct, right? Will it be uglier? Yes, it will be, because this one is set up and ready to go for elimination, right? Elimination would be a lot easier in this problem.
So it doesn't matter.
Okay,
which
because if I were to try to do elimination or substitution for this guy, I have to solve one of these equations for something, right? Okay, so let me show you how ugly this is. Don't write this down. Let's say I want to solve this top guy for x. Okay, if I want to solve for x right here, I have 5x. I would have to subtract the 3y to the other side, right? Okay, so I would have 5x equals -3y minus 19. Are you following? And then I have to get x by itself. So I'm going to divide by 5, divide by 5, divide by 5. So x will be equal to -3/5 y minus 19 over 5. Now that I have this x solved for, I can take this guy and plug it into x right there. Gross, right? -3/5 and -19 over 5, you got to be kidding me. That is disgusting, right? So this one is set up really nice to do elimination with, okay? Elimination is nicer with this problem. Versus this one was really nice because I could just plug one into the other one because the y is already solved for. Does that make sense? So some of them, one is easier to do than the other. Okay, one method is easier than the other. Does that make sense? Yeah? Okay, so let's go on and let's do you remember when we had no solutions versus infinitely many solutions? Okay, so this one up here had one solution. These two lines were crossing each other at one place. Okay, now what does it look like when we have no solutions, when they're not touching? They're parallel lines. So we have two lines that are parallel to each other. Okay, there's that. Infinitely many solutions. What does it look like when we have infinitely many solutions? We have two lines that are on top of each other, right? That's what he looks like. Okay, now we know that when we graph them and they're two lines that are parallel, there's no solutions, right? And we know that if we graph them and there's two lines that are touching each other, that there are infinitely many solutions. But if we're not graphing, how do we determine that? Okay, so that's going to be what these two things are happening here, okay? If something funny happens when you're doing substitution or elimination, it's not probably because you're doing it wrong. It's because it either has no solutions or infinitely many solutions. And I'm going to talk about what those look like right now.
Are both of these questions, are they two different questions, or do they go together as one question?
These are two different questions. A and B. Yep, they're two different questions. Good thought. Okay, so we're going to do A first. Okay, do we want to do elimination or do we want to do substitution on this guy? It doesn't say. You want to do elimination. Okay, so right now if I add the x's together, 5 and 15, that would give me 20. If I add the y's together, 3 and 9, that will give me 12. Nothing cancels out, so I have to do something to one of them. Can you divide the bottom by 3?
Yeah.
No,
Yes.
multiply by 3 on the top one.
We could either divide the bottom by 3 unless the numbers won't divide by 3. Like 54, I don't know if that necessarily divides by 3 evenly, right? So, and I think it does actually. But let's go ahead and let's take the top one and let's multiply it by 3 instead, okay? Because I know that we're going to be safe there. So if we multiply the top by 3, okay? If I multiply by 3, it is 18. You're right. Did you do that in your head? No.
I did it with my
Okay.
calculator.
I'm going to take it times 3, except I want one of them to be negative. So why don't we take it times a -3 to start with? Does that make sense? So I'm going to take -3 times each of these pieces here. It's like distributing a -3 through. So it's -3 times 5x. -15x. -3 times 3y. -9y. What's -3 times 52? -156. -156. Okay, and then the bottom one. I didn't do anything to this bottom equation. He's just going to get dropped down here. So 15x plus 9y is equal to 54. Okay. All right, here's my equal sign. I'm going to drop my equal sign down. Negative 15x plus 15x. What's that give you? 0. 0x or just 0. What's negative 9y plus 9y? 0. So I have 0 on this side. All right, now I have negative 156 plus 54. Negative 102. Is that right? Maybe. I'm pretty sure. Negative 102. Okay, so look at what we have right now. We have something that says 0 is equal to negative 102.
Does it need to be 0 or less than?
Nope. Nope. It always stays equal to. Okay?
So.
How does that make sense? 0 is equal to negative 102.
It's parallel.
It doesn't make sense. It doesn't make sense. 0 is never negative or is never equal to negative 102. So in this case, there are 0 solutions, right? 0 is never equal to 102, so 0 solutions, right? So what would these look like if you were to graph those two lines?
Parallel.
They would be parallel. They would be two parallel lines. Parallel. Does that make sense? No solutions. So when you're doing substitution elimination, if you get to something where you're like, I don't have an x or a y anymore, it's because everything crossed out and you have something that's no solutions.
When you do infinite many solutions,
Like this one.
it would be number equals the same number.
Oh my gosh,
Yeah.
you're so brilliant, so brilliant. Should we try to do substitution with this one?
No.
But you're gonna have to know how to do substitution.
So.
Let's do elimination with this one, and maybe I'll do a homework problem with you. That's substitution. How about that? Can we do that? Okay, sure. We'll compromise. All right, now we want to eliminate. We want to eliminate. So, which variable would you like to eliminate? The x or the y? Y. Okay, so this one is 3 and this one is negative 6. I want this to be the same number, but one of them be negative and one of them be positive.
Take the top one by negative 2.
If I take the top one by negative 2, they'll both be negative 6s. I want one of them to be positive.
Okay, take the top one by
Take
2.
the bottom.
Let's just take the top one times 2. Right? Let's take the top one times 2. All right, because then that 3 will turn to a positive 6. So take them times 2 times 2 times 2. 2 times 2x is 4x. 2 times 3y. 6y. 2 times 15? 30. Okay? Now, on the bottom, I have negative 4x minus 6y is equal to negative 30. Okay, here's my equal sign. I'm going to drop him down. Oh, man. 4x minus 4x. He's gone. 6y minus 6y. He's gone. So what's on the left side? 0 here, right? Everything's gone. So I put 0. 30 minus 30 is 0. So I have 0 equals 0. When does 0 equal 0?
When every solution is possible.
All the time. 0 is always equal to 0, right? 0 equals 0 all day long. So there are infinitely many solutions. That's an infinity sign, or you can just say infinite solutions. So what do these two things look like? What do those two lines look like?
One line.
One line on top of each other, right? That's what he looks like. Infinitely many solutions. So when you get something like that, 0 equals 0, or sometimes maybe it's not 0. Sometimes maybe you get the answer like 2 equals 2, or sometimes you'll get the answer like 7 equals 7. Okay? When does 2 equal 2? All the time. When does 7 equal 7? All the time. So there are infinitely many solutions in that case. Does that make sense? It doesn't necessarily have to be 0 and 0. Did that answer your question? Yeah. Okay. All right. Should we do one more from your homework? We'll do a substitution one just to give you more practice with substitution. This is number, what's the first one? 14 that you have to do?
Yeah.
Let's do number 14 together. Maybe? Actually, I'm going to change my mind. Can I change my mind? 14 is easier than 16. We'll do a harder one. We'll do 16 together. Okay, will you read me 16? Somebody who's got their book out. A,
What page is that?
page 47.
A minus 3b
How's that page
equals
46?
negative 22. And then 4a plus 2b equals negative 4.
Okay, they want us to do substitution with this guy. So in order to substitute, I have to be able to plug something in. But in order to plug something in, I have to have one of my variables solved for. I have to have either A equals something or B equals something, right? Do I have A equals something or B equals something here? I'll wait for you guys to write this stuff down.
What was your question?
Hold on. We'll wait for them to write stuff down. Okay, so I need to get A by itself or B by itself. Do I have either A by itself or B by itself for one of those two equations at all?
No. But you want to
You
get.
have A by itself.
Well, but he's not alone on one side of the equal sign by himself.
Yeah, but it's just easier to get.
Yeah, so we can get him by himself, okay? So we want to be able to have like A equals a bunch of junk or B equals a bunch of junk. And we don't have that right now because the equal sign, A and B are both on the same side of the equal sign. So we've got to move some stuff. So here are my options. Here are my options. And some of you guys know which one's easiest already. I either want to solve for this A, solve for this B, solve for this A, or solve for this B. Which one would you like to do? A in the top. That is the easiest one to do because you don't have a number in front of A. So we want to get this A by itself. All right. So we want to kick the B to the other side. How do you kick the B?
Add it over.
Plus 3B plus 3B. Okay. So now I will have A equals. What will that look like? If I kick the B to the other side.
Minus 22.
3B minus 22. You betcha. Okay. Now I have A by itself. I have A solved for. Now what do I do?
Put it into.
Now I literally do substitution. So I take this guy and he can plug it in for A on the bottom. Now whichever one you solve for to start with, you don't want to end up plugging it back into that one, right? We solved A in the top equation. So I wouldn't want to take A and plug it in up here, right, for that A, because everything's going to cancel out and it's going to be nasty. So I want to plug him into the bottom one. So I have 4 times A. And A is now 3B minus 22. You see that 4A right here is now 4 times 3B minus 22. And then I have plus 2B equals negative 4. You see that? 4A plus 2B equals negative 4. That's what this guy said. But now I'm plugging that thing in for A. Good?
Will you multiply 4 through?
So we're going to multiply the 4 through. We're going to distribute him for both of those pieces. 4, right? The second one too, Chase? 4 times 22 also. You don't just take it times 3, right? 12B minus 88. Did you do that in your head?
Yeah.
Good for you. Plus 2B equals negative 4. Okay, we're getting close. We're almost there.
Why do
It'd
we
be
have to do it
easier
this
just
way?
to graph it.
We
Huh?
just
You
do
think it'd
it-
be easier just to graph it?
Why can't we
We're
just-
going in slow mo because this is like the first time you've seen this. Once you really start doing it, it goes a lot faster.
Why can't we
Okay.
use elimination on this?
I don't know. I don't know. Okay, so let's put stuff together. What can you put together?
The
The
negative
B's.
8 and negative 4.
Let's go the B's first. 12B and 2B. 14B minus 88 equals negative 4. Yeah, are we good? Okay, then let's kick the 88 to the other side. So add 88 plus 88. 14B is equal to 84. And then what? Divide by 14, divide by 14. B is equal to 6. Beautiful. Done? No.
So is the answer just b equals 6?
No.
You just wait.
We have
B
to
equals
put
6.
that
Now
in.
we have to find
Oh.
A. Okay, so here are my top two equations. I have A is equal to this, or A is equal to this. But the place that I want to plug into, didn't we solve for A right here?
No.
So why don't we plug it into that one? Because A is already solved for. A is equal to 3B minus 22, but B is 6. Okay, does that make sense? Yeah? So 3 times 6 is 18. What's 18 minus 22?
Three.
4.
Negative 4. Negative 4. So if I write my answer A comma B, it will be the point negative 4 comma 6. That's how we'll write our answer. Okay?
How do you know which one's which?
I don't know. I always just go the first
So
one,
won't that be
like
one
alphabetically, which one is which. Obviously, XY goes XY, right? But if it's other letters, I usually just go which one is first alphabetically. So
you won't
A
get
comes
that.
before B. If you would switch those around and it's not like an XY and you would say 6 negative 4, I would count it right because you don't know which one technically goes first. Does that make sense? If it's XY and you flip them around, yeah, you're gonna get it wrong. But
Right, how many solutions are
not on that one. There is a section though I think they ask you how many solutions there are.
We should do 18 too.
No, you try 18 by yourself. Okay, but what do I care about at this point? What happens here?
What?
What
Oh, we don't.
happens
I didn't see.
here?
Okay.
What happens here?
The
That's
point of
break
equal
line.
livocation.
The two lines cross.
Do we have to put that down?
No.
But I will ask you that a lot. I will say, why do we care? Because if you're solving for it and you get negative 4, 6, that's great. But if you don't know what you're solving for, that's like, why are we even doing it, right? So 2 lines cross each other at that point. This is substitution. Ugh, that looks like a lot of work, but the more you do it, the easier it gets. I promise, and it'll be faster.
So
And it's better than graphing.
in the future, like on the test, and it gives us an equation, can we
Yeah.
do elimination with it?
Can you choose what to do? I think for Algebra 2, I make you guys do one of each.
What if we like do it?
But I make the one really nicely set up so that you can substitute really nice. So it would be better to substitute because it's like
Okay.
already kind of ready, you know? Like, yeah. So there you go. Okay? Good? All right. Okay, you have like 5 homework problems now. Woo woo. And you've got 25 minutes. Go.
Oh, that's not enough time.
5 minutes for a problem. And it didn't take that long. Everybody say bye, Claire. I don't know how to get this off. Here we go.
It didn't even go.